quadratics and solving quadratics. And today we're going to talk about the vertex form of a quadratic equation. We've seen it before, we've never made it, so now we're going to take standard form and rewrite it in vertex form. And then once we've done that, we're going to describe the transformations. We're going to identify the new vertex, and then we're going to identify the axis of symmetry. So ready, set, here we go. Normally, I give you a big picture and then I work through examples. I'm going to do it a little bit different. First, let's kind of talk about just comparing what the two forms look like. The standard form is what we're used to working with all this month, basically. F of x equals ax squared plus bx plus c. It also could be y equals ax squared plus bx plus c. Doesn't matter. The vertex form is f of x or y equals plus or minus the coefficient a times x minus h, and that whole thing squared, plus k. So we've seen something really similar to this. We've actually used different letters in here for h and k, but when we're in this vertex form, the number that's being subtracted from x, that gives us the x-coordinate of our vertex, and the number at the end is giving us the y-coordinate of our vertex. The transformations stay the same. It's what we're used to. If there's a negative out in front, we are reflected down. If it's a positive, then our graph remains opened up. A is the dilation. It tells us how fast it increases. If A, without looking at the sign of A, that's what the absolute value bars mean, just look at the value of A, the units of A. If it's bigger than 1, like 1.5, or 2, or 10, or 5.5, the parabola is stretched. And then if it's a fraction between 0 and 1, then the parabola is compressed. Our horizontal shift comes from looking at that piece that's getting squared, x minus h. That's going to shift our parabola right h units. Remember, it shifts in the opposite direction inside the squared term. If we have x plus h inside the squared term, then it's going to shift it left, shifts it in the opposite direction. Our vertical shift comes from k. If k is positive, it's going to go up. If k is down, it's going to go negative. And our vertex is going to be h comma k. Now, when you do this, h comma k, it's the opposite sign of h and then the same sign of k. Sometimes that gets a little confusing. And then our axis of symmetry is the line x equals whatever our x-coordinate is in our vertex. So these two are the same. X equals the value of h. Okay? So let's see what this kind of looks like when we do this. All right? So we're going to rewrite this from standard form into vertex form, and then we're going to describe the transformations. So our first step is to take f of x and group those first two terms, and I'm going to leave some space here because I'm going to be adding something. I'm going to be completing the square inside there. Okay, so that's step one. And I don't have to worry about my coefficient a because here it's 1. If it's not 1, you got to do something different first, and we'll talk about that in a couple slides. All right, my 5 looks kind of like an S, so this is a 5. Okay, now I'm going to complete the square in here. Okay, we're going to complete the square. We know how to do that. We're going to take half of b, so 4 divided by 2 is 2, and then we're going to square it. 2 squared is equal to 4. So I'm going to add 4 in there, so I have f of x is equal to x squared plus 4x plus 4. All right, and now I have this negative 5. Now, think about what we've done. We've actually changed the value of this equation because we've added 4 units here. So if I want something to stay the same and I've added 4 units here, what do you think I need to do here? I need to subtract. So I have to, whatever I add on the inside of my parentheses, I have to subtract from the outside of my parenthesis. Okay? Now here we've created a perfect square trinomial. That was our goal, so we're going to factor that. So we get f of x is equal to x plus 2 squared, and then we're going to add negative 5 minus 4. We're going to combine that, and we get minus 9. Right? Now we're going to talk about our transformations. Is there a negative sign in front? No, so there's no reflection. Is there an a other than 1? No, so there's no dilation. Am I shifted left or right? I'm shifted in the opposite direction. So I'm shifted left 2, and I'm shifted down 9. So my vertex from 0, 0, because that's where my parent curve is negative 2, negative 9. And my axis of symmetry is the value x equals negative 2. This is h, and this is k. This is h, and this is k. So remember I said take the opposite of h and then the value of k. Opposite sign of h, same sign as k. Okay? Let's try another one. This one's going to give us a fraction, but we're not going to be afraid. Right? So we're going to group the first two terms. Notice that this one is y. F of x and y are the same thing. X squared minus 11x plus 31. I'm going to complete the square on the inside here. Complete the square here. So I get y equals x squared minus 11x. All right, so we're going to take negative 11, divide it by 2, and square it. So I get plus 121 over 4. And then, think about this, I've added this much into it. So now I have to subtract off that same amount on the outside. Okay? This first part factors. So I get y equals x minus 11 halves squared, and then I have to combine this. So remember, the easiest way to take 31 and write it is fourths, is to multiply 31 times 4, so that's 124 over 4 minus, and then this stays 121 over 4. So I get plus 3/4. So now I'm going to talk about my transformations. There isn't a negative out in front, so it's no reflection. A is 1, so there's no dilation. I'm shifted right 11 halves. I'm shifted up 3/4. So my vertex is 11 halves 3/4. And my axis of symmetry, x equals whatever h is. This is h and this is k. Look, the opposite of 11 halves, a positive 11 halves, the same sign as k. So this is h and k. So 11 halves. Okay, so I alluded to the fact, what do we do if we have a coefficient a that's not 1? So the first thing we're going to do is we're going to factor that out. So I'm going to get f of x, which is the same as y, and I'm just going to factor it out of my first two terms, and I'm going to show you why I can do that. I'm going to factor out a negative 3, so that gives me x squared plus 6x, and then I'm going to leave a space, and then I have 10 on the outside. Okay? Okay. Now I'm going to complete the square on the inside. So I have f of x is equal to negative 3 x squared plus 6x. Now take half of 6, that's 3, and square it, plus 9, okay? And then I have plus 10, all right? Now we have to think about what we have to subtract on the outside here. What have I really introduced into this equation? I've actually introduced 9 units times negative 3. So I've introduced negative 27. So to keep it balanced, I'm going to have to add 27 over here. I introduced negative 27 units on this side by completing the square and then multiplying it by negative 3. So that means I have to add it on the outside, okay? So this is, I'm subtracting, I'm just doing the opposite. So this would be add here, okay? All right. And now we have to factor. So I get f of x is equal to negative 3 times x plus 3 squared plus 37. And now we're going to talk about the transformations. This is reflected because there's a negative sign out in front. It has a dilation of a stretch because 3 is bigger than 1. It's shifted left 3 and up 37. So that means my vertex is negative 3, positive 37. And my axis of symmetry is x equals negative 3. Okay? So this is kind of what we did in a nutshell. Sorry about Eli. And basically, I grouped my first two terms, and then I completed the square, and then whatever I did on the inside, I did the opposite of it on the outside, and then I factored, right? Again, I'm sorry. And then once I factored, then I wrote my equation. I'm sorry that my dog barked, but I'm right at the end, so I'm going to leave him in there. Thanks for listening.